Hi, and welcome back, everyone. Today we're going to take a look at factorizing some more difficult questions, some of the more difficult, essentially quadratics that we are going to face. So when it comes down to quadratics like this, where essentially the leading coefficients, the leading coefficient is not equal to 1. Over here, as you can see, the leading coefficient is not equal to 1. How do we deal with these? First of all, we have to see whether we can factorize out of a common number between them. And over here, there's no common number between them. So how do we factorize it then? Well, one of the best ways that I like is to draw this sign, right? So the multiplication sign. And then you write a times c, which is the leading coefficient multiplied by c, which is 12. And then this is b, right? You have to be able to identify the coefficients. And write b over here. So what does this mean? First, you got to think about a number that multiplies to 2 times 12, that is 24, but adds up to 11. So once again, multiplies to AC, which is 2 times 12, but adds up to B. All right, now if you think about two numbers that essentially multiply to 24, but add up to 11, let's think about it. So a bunch of numbers multiply to 24, and one of them is 6 times 4. But 6 times 4 does not add up to 11, right? So it does not add up to 11. It actually adds up to 10. So it's not going to work. What about another number which multiplies to 24 is obviously 8 times 3. Now we know that 8 times 3 is going to give us 24. And if we add 8 to 3, we're going to get 11, right? Because 8 plus 3 is essentially 11. All right. So the two numbers are 8 and 3. 8 times 3 multiplies to 24 and adds up to 11. All right. Now, the next step is pretty simple. So you just write 2a squared plus 11a plus 12. Then you decompose the middle term, right? The middle term, 11a, the one with the essentially the variable that has a power of 1, because over here a is raised to the power of 1. You decompose it into 8a and 3a. So it actually adds up to 11a, right? Now, you write 2a squared plus 8a plus 3a plus 12. Now, sometimes, as you can see, we can now factor out of these two sides. So we have two factors within these two brackets, but sometimes the numbers have to be like interchanged. For example, 3a has to be brought to this side because it makes it has a greatest common factor with the other number. And you'll see what I mean when I go ahead, if such example shows up. But over here, you just have to factorize out of the greatest common factor between them. Here you have 2 times a times a. Here you have 4 times 2 times a. So the greatest common factor between them would essentially be 2, right? And what about anything else? A right there. So you can just take 2a outside of that bracket. Now what multiplies with 2a to give you 2a squared? That would be a. And what multiplies with 2a to give you 8a? That would be 4a. Okay. My bad. 4. All right. Now out of the other bracket, you can also factorize out of 3 because this is 3 times a and this is 4 times 3. So the 4 can be factored out since it's the greatest common factor, the 3. So you bring 3 out and you will have a plus 4. Now, as you can see, these two brackets are the same. When you reach this point, you can be sure that you've done your factorization correctly. So you will have 2a plus 3 and you will have a plus 4 as your two factors. And both of them are obviously equal to 0. This is a equation. All right, now using the essentially the null product law, you can just go ahead and say 2a plus 3 is equal to 0 and a plus 4 is equal to 0. So your two roots are, just bring 3 to the other side, 2a is equal to negative 3 and a is equal to negative 3 over 2. I basically divided this side by 2, which means I have to divide this side by 2 as well. So this is one of the roots, and for the other one, it's pretty simple. Just bring 4 to the other side, and that gives you negative 4. All right, so this is how you factorize some of the more harder problems when it comes down to essentially factorizing quadratics. Let's go ahead and do another one just to be sure. So over here, once again, you just draw that sign, multiplication sign. Well, multiplies to AC but adds up to B. So multiplies to 30 because A is 3 and C is 10, but adds up to 17. All right, now two possible numbers add up to 30. Actually, 3 and 10 and 15 and 2. and obviously it's 15 and 2 because 15 plus 2 is 17. So once again, you decompose the middle term into two terms that add up to it. That's 15x and 2x. So you write it as 3x squared plus 15x plus 2x plus 10 is equal to 0. All right, now you just factor out of the common terms, which would be over here. It would be essentially 3x, which would be what would be left on the inside would actually be, so what multiplies with 3x to give you 3x squared, that would be x. And what multiplies with 3x to give you 15x, that's 5. Now, if you essentially you have this, and then out of the other bracket, you can also factor out of 2, which would give you x plus 5 is equal to 0. All right. Now, the two factors that, obviously these two are just repetitive. You don't have to write them twice. You just write 3x plus 2. That's the other factor. And the other one is obviously x plus 5, which is equal to 0. So you just put them both equal to 0. 3x plus 2 is equal to 0. And x plus 5 is equal to 0. So 3x is equal to negative 2. And because I brought 2 to the other side, now divide both sides by 3. And x is equal to negative 2 over 3. As for the other number, you just bring 5 to the other side, and x is equal to negative 5. There you go. Thank you for watching, and good luck.